Welcome back to YÖS ALFA. I'm Salman and I'll be taking you through the math part of our 6th trial exam. For those of you who'd like to give it a try before continuing this video, the PDF of the exam is available in the description down below. Let's get started. Number 1. X and y are integers, and this expression is given. Y is always odd. This is not true. We can easily show that when x is equal to 2, we have 4 times 5 is 20. 20 minus 2 over 3 is 6. So y is even. So this statement is false. The second one, if y is odd, x can be 0. Let's try and substitute x is equal to 0. When x is 0, we have 5 minus 2 over 3. So y is 1. So this statement is true. When x is equal to 0, y is odd number. Statement number 3. If x is a positive integer, y can be even. Okay, in the first case, when x was 2, we got y is equal to 6. So statement 3 is talking about this situation. When x is a positive integer, y is even. So this is also true. So the answer is D. 2. X, Y, Z are positive integers. This expression is given, and which of the following is always even? So we can write this expression as x times y minus z is equal to 35. Since 35 is odd number, we know that the multiplication of the two odd numbers gives us the odd number. So from this statement, we know that x is odd and y minus z is also odd. So to have an odd number out of these two, we know that one of them must be an even number. So either y or z is even. So in the choice B, we have both y and z, since we know for sure that one of them is even. And we also know that the multiplication of an even number with any number is even. The answer is B. 3. X is less than y, which means x minus y is less than 0. And this is less than 0, which means this expression has to be less than 0 too. Since z squared is a positive term, to make this expression negative, y has to be negative. If y is a negative number, any number which is less than a negative number is also a negative number. So x and y are both negatives, but we can't say anything for sure about z. And the question asks, which ones of the following can we say for sure that they are either positive or negative? So the answer is B. 4. A is a negative number and D is a positive number. So A is negative and D is positive. According to this, B and C have the same sign. So to make this expression less than 0, B and C must have the same sign. They are either positive or negative. If they are one positive and one negative, then we're going to have a negative value. Negative value times another negative value give us a positive value, which is against the given statement. So B and C have the same sign is correct. And B is negative. B is either positive or negative, as we can see here. So this statement is not certain. 3. The smallest of these four numbers is A. We know that A is negative, and to have a positive value, B and C must be positive because they have to have the same signs. If they're both negatives, then we're going to have a negative value, which is not positive as it is given. So since B and C are both positive, A has to be the smallest of all. So 3 is also correct. So 1 and 3 are correct. The answer is D. 5. The two expressions are given. Which of the following can be the signs of x, y, and z? X squared is a positive term, so y has to be negative. If y is negative, to have a positive, z must be negative too. So we cannot say anything for sure about x, but we know for sure that y and z are negative. Y and z are negative here. So this is the only condition with y and z negative. So the answer is B. 6. This table is given, and we're asked to find the sum of the numbers in the 10th row of this table. So this is a number series. On the first row, we have 1 cube. In the second row, we have 2 cube. In the third row, we have 27, which is 3 cube. So in the fourth row, we have 64, which is 4 cubed. So that means in the 10th row, we're going to have 10 cubed. So the answer is 1,000. It's D. 7. What is the value of x that satisfies the equality? We have the summation from 1 to 17 and they're all odd numbers. So the formula for odd series is n squared. Since we have 9 terms, the summation is 9 squared. On the right hand side of the equation, we can factor out 7 factorial. So we have 1 plus 8 plus 9 times 8. 9 times 8 is 72. This is 80 and 81. So the 81 from left hand side and the right hand side cancel out each other. So we're left with x is equal to 7 factorial. So the answer is B. 8. AB0B and A0BA are 4-digit numbers, and the sum of the salaries of two people in the table is this. So we're given the sum of these two. Let's write it down. AB0B and A0BA. The summation is 12561. We're asked to find how much A is larger than B. So B plus A is 1. I'm going to assume that it is 11. So we'll have 1 over here. B plus 1 is 6, which means B is 5. So 5 plus 0 is 5. A plus A is 12. So A must be 6. So everything checks out, which means our initial assumption was correct. So A is 1 larger than B. So the answer is B. 9. This expression is given. How many different 3-digit natural numbers m and k can be written such that the number m is the square root of the number k? So that's the most important part. So m is square root of k. And we're asked to write difference m and k. So how many different m and k's do we have? M is larger than 1. So let's say m is 2. If m is 2, then k is 4. Since 4 is not larger than 7, this is impossible. So the next one is, let's say m is 3, then k has to be 9. How about m is equal to 4? If m is 4, then k is 16. Then 16 is no longer a digit anymore. Each of them, m and k, is a digit. So this is also impossible. So we have only one possible value for m and k. So m is 3, that means n can be 4, 5, and 6 because all three of them are less than 7. So our possible m and k are 349 and 359 and 369. So there are 3 of them. So the answer is C. 10. What is the degree of the polynomial a of x squared plus b of x to the 4? So let's write down the polynomial a of x. I'm going to write down, let's say, the highest power only. And the highest power is x to the a. For the polynomial b, we have the highest power b, let's say. So for a cube x, we're going to have cube of this polynomial. So the highest power will become x to the 3a. And for b of x squared, we'll have x to the 2 to the b plus the polynomial. So the one with the highest power is x to the 3a, and the one with the highest power over here is x to the 2b. Since we are multiplying these two polynomial, we're going to sum up the highest power. So we have 3a plus 2b. Since the degree of the polynomial is decided only by its highest power, so we can write 3a plus 2b is equal to the degree, which is 18. From the second equation, we can write just like the first one, ax squared is 2a, and since it is a division, we're going to subtract the powers. B squared x is 2b, and the degree is 2. So we have 2 equations and 2 unknowns. We can sum them up. We have 5a is equal to 20, a is equal to 4. If a is 4, then b is 3. So we're asked to find the degree of the summation of the two polynomials, ax squared. So the highest power of this will be x to the 2a. And for this one, we'll have the highest power, x to the 4b. Since a is 4 and b is 3, we have x to the 8 plus x to the 12. Since we're talking about the degree of the summation, we can take the highest power as the degree of the summation of the two polynomials. So the answer is 12. 11. This number has 20 positive odd divisors. How many positive even divisors does it have? So to talk about the positive divisors, we need to prime factorize this expression first. Let's do that. So 12 is the same as 2 squared times 3, and 10 to the x is the same as 2 to the x times 5 to the x. So when we simplify this, we have 2 to the 2 plus x times 3 to the 1 times 5 to the x. And we know that to find out the total positive divisors, we can increase the power of each prime numbers here by 1 and multiply it. So total divisors, positive divisors, is 2 plus x plus 1 times 1 plus 1 times x plus 1. And we know that the odd divisors can come only from this 3 and 5. Whenever we have 2, we're going to have the even divisor. So we'll take care of this part only for now to equate it with this 20 here. So the odd divisors are coming from this part. So 2 times x plus 1 is equal to 20. So from here, x is equal to 9. So let's substitute this value into this expression to get the total number of divisors. So when x is equal to 9, we have 12 times 2 times 10, which is 240. We're asked to find the even divisors. We can have the even divisors when we take away the odd divisors from the total number of positive divisors. So there are 20 odd divisors. So that means the rest is the even divisors. So 240 minus 20 is 220. So the answer is E, 12. A is a positive integer, and A squared has 6 integer divisors. In this 6 integer divisors, it includes both positive and negative divisors. We're going to focus only on the positive integer divisors, which is 3. There is also 3 negative same integer divisors. So to find out the number of positive integer divisors, we prime factorize the number first, and then we add the power of those prime factors by 1. In this case, 2 plus 1 is already 3, which means that A has to be a prime. If A is not a prime, we'll be having more than 3 divisors. So let's take a look at this. Number 1, A is a prime number. We already got this conclusion from this statement. So number 1 is true. Number 2, A cannot be an even number. Since A is a prime and 2 is also a prime number, A can be 2, which means A can also be an even number. So this statement is incorrect. And for this, there are 5 values of A. So A is a prime. So it could be 2 squared, 3 squared, 5 squared, and 7 squared. It's already 49, so this one is not included. We have only 3 values of A between this range. It's not 5, so this one is also incorrect. So the only correct statement is 1. So the answer is A. 13. The two polynomials are given, and the constant term when a of x is divided by this is as b of x is here. Let's insert b of x over here to the first equation. So we have a of x is equal to x minus 1 times, instead of b of x, we'll have x minus 3 times c of x plus 4 plus 7 over here. When we make the multiplication, we have x minus 1 times x minus 3 times c of x plus 4x minus 4 plus 7. And so this 7 minus 4 is 3. And this is a of x. And we're going to divide this a of x by this. This is the same as x minus 3 times x minus 1. So we're going to divide the whole thing by x minus 3, x minus 1. Since this one is divisible, we're not going to have any remainder from the first part. From the second part, we have 4x plus 3, which is a first order equation. And we're dividing it by the second order equation, x minus 3, x minus 1. So the remainder is going to be the first order, which is 4x plus 3. So that is the remainder of a of x. And since we are asked to find the constant term of this remainder only, the answer is B. 14. X and y are integers, and the highest common factor is equal to this one. And we can easily find the highest common factor from the given expression. 18 times 7 is 126. 18 times 4 is 72. So the highest common factor here is 18. So this expression is equal to 18. When we divide both sides of the equation by 18, we get 7x plus 4y is equal to 1. So the question asks, what could be the sum of the values of x and y? So one of the pairs of x and y that could satisfy this expression is when y is equal to 2 and x is equal to minus 1. We have 8 minus 7, and the summation is 1. So x plus y is 2 minus 1. It's 1. The answer is B. 15. HCF, highest common factor, is given to be x. What is the sum of the positive integer values of x? So highest common factor is x. it means that we can factor out x, and what's left inside the bracket would be 1, 2 plus 18 over x. Since HCF is given to be x, 18 must be divisible by x. So x could be 1, 2, 3, 6, 9, and 18. So since we're asked to find the summation, the answer is the summation of all these numbers, which is 39. The answer is E, 16. F of x minus 3 is equal to 6. From here we have f inverse of 6 is equal to x minus 3. And the f of x graph is given. F inverse of 6 is the x values when y is equal to 6. So when y is equal to 6, we have x value here and there and here and here. So we have 4 different x values. They are minus 5, minus 2, 2, and 7. So which means x is equal to minus 5 plus 3, and we're going to have plus 3 4 times. And sigma x is the summation of all these. So we have minus 2 and 2 cancel out each other. 7 and minus 5 is 2. And we got 3 times 4. 12 plus 2 is 14. So the answer is E, 17. The graph is given, and f inverse of 4 is 5. And g of 3 is asked. So to get a g of 3, we can add x is equal to 6. So we have f of g of 3 is equal to, when x is 6, this graph gives us 4. From here, g of 3 is equal to f inverse of 4, and f inverse of 4 is given as 5. So the answer is E, 18. What is the sum of the values of k and l that satisfy the equation? So let's solve this equation. 1 over k plus 3 is equal to minus 1 over l minus 2. Let's cross multiply this. We have l minus 2 is equal to minus k minus 3. From here, l plus k is equal to minus 3 plus 2, which is minus 1. So the answer is C, 19. X squared is asked. So let's multiply these two equations. So we have x minus 1 times x plus 1 is equal to a over b times b over a. So we have x squared minus 1 is equal to 1. From here we have x squared is equal to 2. The answer is B. 20. Integers are written in the boxes in increasing order from left to right. So from left to right, the numbers are increasing. And we're asked to find the maximum of y minus x. So the maximum y is less than 10, and it has to be an integer. So it is 9. To maximize y minus x, x has to be the minimum, which is larger than minus 3. So it's minus 2. So the difference is 9 minus 2, which is 11. The answer is A. 21. Which one of the following represent the shaded region? So first of all, the shaded region is below x-axis, which means y negative values. So y is less than or equal to 0. If y is less than only, we would see a dashed line here, something like this. But since there is no dash line, that equal sign is there. So y is less than 0 for the first one. And for the second one, we need to know the equation of this line. So let's find out the equation of this line. Y is equal to mx plus c. Since the slope is rise over run. The rise is 4, run is 2. So 4 over 2 is 2. So we have 2x, and when x is 0, our y must be 0 too. So c is 0. So this is our equation. Y is equal to 2x. Since the shaded region is below this line, it is less than 2x. So y is less than 2x. And the equal sign is, again, it's there because we don't have a dash line here, something like this. If we have something like this, that means this line is not included. Then we wouldn't have the equal sign there. Okay. So the answer is E, 22. According to this, what is the sum of the integer values that this expression can take? So this expression is m plus n the whole square. So to get m plus n, we can write this expression this way. So minus 4 is over here, and n comes here. So we're left with 7 minus 4, which is 3. When we square this, m plus n the whole square, let's square this and that. So I have 9 and 16. So the maximum for this would be 16. And since we have the equal sign here, I'm going to add the equal over here too. And the minimum of this is 0, because m plus n the whole square means it's a positive number. it can never go down below 0. So it's between 0 and 16. So we're asked to find the summation of all the possible integer values between 0 and 16. So let's write down those integer values. 1, 2, 3, it keeps going up until 16. So the summation is 16 times 17 over 2, which is 136. So the answer is A. 23. For the values of P and Q that make the sum, this sum, the smallest, what is the solution set of this equation? So to make this sum smallest, we know that the minimum possible value for the summation of two of the absolute values is when both of this expression are equal to 0. So that is the minimum possible value for the summation. So this happens when Q is equal to 7 and P is equal to minus 7. So we got the values of P and Q. Now let's substitute those values into this expression to find out the solution set of this equation. So P is minus 7 and Q is 7. From this equation, it is equal to 0. So the absolute value of x is equal to minus 7 over minus 7, which is 1. So x is either positive 1 or negative 1. So the solution set is D. 24. This equation is given, and this one is given, this one is asked. So this is the same as x prime intersection y prime. So which is what's given here. So we're asked to find this one, and this one is 20. So this one is nothing but the one given here. So this one is 20. So 20 times 2 is 40. So 40 over 5 is this one, the answer. So it's 8. C. 25. This is given. This one is asked. So there is a clue for us. We have 1 over x plus 2 over here. If we have x plus 2, then we can relate the two expressions. So I'm going to add up 2 to both sides of the equation. So we have 5 is equal to this expression. So I'm going to square both sides of the equation. So we have 25 is equal to x plus 2 the whole square plus 1 over x plus 2 the whole square plus 2 times this and that. So 2 plus x and x plus 2 cancel out each other. We have 2 left only. So this is A. So our answer is 25 minus 2, which is 23. E. 26. According to this expression, which of the following is equal to the expression x to the 5 minus 2x cubed in terms of x? So let's factor out x cubed. So we have x squared minus 2 over here, and x cubed can be written as x times x squared. So we know that x squared is 1 plus root 2. So we have 1 plus root 2 minus 2 times 1 plus root 2, which is x squared, times x. So this is root 2 minus 1. This is root 2 plus 1. So we have root 2 plus 1, root 2 minus 1, which is root 2 squared minus 1 squared times x. This is 2 minus 1, which is 1. So the answer is x. 27. Number of the elements of x prime is the same as number of the elements of the universal set minus number of the elements of x, and number of the elements of set x is equal to 35. When we sum them up, we have number of the elements of the universal set is equal to 50, and from this expression, we can write number of the elements of y prime is the same as number of the elements of the universal set minus number of the elements of the set y, and it's given to be 20. So this one is 50. So number of the elements of set y is 50 minus 20, which is 30. The answer is E. 28. The graph below shows the amount of growth in the height of two saplings. Y-axis is the height and x-axis is the time or year. According to this, after at least how many years will one of the two saplings planted at the same time reach twice the height of the other? So y-axis is the height, x-axis is the year. So we are given the height ratio. Let's say this is y1 and this is y2. The height ratio is 2. And we're asked to find the time when that happens. So let's find out the equation of y1 and y2. So since this is a linear equation, we need to know the slope of the equation first. The slope is rise over run. Rise is the difference between these two, which is 6, and run is 3. So 6 over 3 x plus the constant. When y is 0, our x is 44. So we have 44 here. So we got first equation. In the same way, we can find the second equation. We use this point So rise is 10, run is 2. So 10 over 2, x plus 1. X is 0, y is 10. So we got this equation 2. So let's use these two equations in this ratio and find out the year x. So y1 is 2y2. So y1 is 2x plus 44. Y2 is 5x plus 10. So let's divide both sides of the equation by 2. So we have x plus 22 is equal to 5x plus 10. 4x is equal to 12. X is equal to 3. So this means after 3 years, their height ratio will be 2. So the answer is A, 29. M and N are integers, and this is given. Let's simplify this. 3m minus 3n is equal to n. From here we have 3m is equal to 4n. So the ratio of m and n is 4 over 3. From here we have m is equal to 4x and n is equal to 3x. And let's substitute these values into this expression. So we have 4x plus 3x, which is 7x between 10 and 30. And the expression p is given as n minus 2m. n is 3x and m is 4x. So from here we have minus 5x. So we're asked to find the minimum value of p. So we have this expression. Let's write it down one more time. 7x between 10 and 30. So we went negative 5x. So I'm going to multiply this by negative 5 over 7. So we have negative 5x here. So let me multiply both sides of the inequality by negative 5 over 7. If I do that, the result is going to be minus 150 over 7. This is minus 5x, which is p at the same time. And this one is minus 50 over 7. Since we're asked to find the minimum value only, I'm going to be calculating just this part. So this is 7 times 2, 14, and 10 left. 7 times 1, 3 left. So we have 21 point something. So p is larger than minus 21. So the minimum possible value for p is minus 20 from this. So the answer is D, 30. X over y is given, and y over z is also given as 3 over 2. So in order to write down the ratio, I'm going to make the y's equal. So since we have y6 here, I'll multiply both numerator and denominator by 2. So we have 6 over 4. Now that we have y equal, we can take the ratio as x, y, and z as 5 and 6, and z is 4. So we have this. So this is our ratio. Since we don't have this in our answer choice, but we have this one. This one is obtained 1. This is multiplied by 2. So we have 10, 12, and 8. So the answer is A, 31. Before we solve this problem, let me refresh your knowledge of the triangle ratio with respect to the base. So whenever we have two triangles or more than two triangles, doesn't matter, and the height of the triangles are the same. For example, we have ABC and ACD. So both triangles have the common height h. We can take their area ratio as the base ratio. Let's say this is A, this is 2A, then the area ratio A over 2A is the same as the base ratio BC over CD. So this is 1 over 2. So we'll keep using this stuff in this problem. Now let's come back to the problem. RP is parallel to VS. VS is this line. Since it is parallel, we know that this ratio is the same as this ratio. Since the ratio is 1, this dual ratio OQ over QT must be 1, 2. So now let's connect T and R, and now we have two triangles here, and they have equal bases. And they also have a common height over here, which I'm not gonna draw here because it's gonna confuse you at some point. So now they have equal bases. That means their area are the same. If this is A, this one is also A. And now let's take a look at this triangle, and we can divide this triangle into two from here. And since these two have equal bases, their area must be the same too. This one, if this one is 2A, this one must be 2A too. So let me write it over here. This is 2A. And let's take a look at this triangle from the vertex R. Since these two triangles have equal height, we can talk about the area and the base ratio. Since the base ratio is 1, the area ratio must be 1, 2. So if this is A, this is also A. And we already know that the summation of these two must be 2A. So we got this. And now let's take a look at this triangle and that triangle. So the vertex is O, and we can talk about the area ratio because we know their basis ratio, this and that, is 2 and 1. So we have the base ratio 2 and 1. So the area ratio must be the same as the base ratio. So we have 4A for the entire area for OTV. So that means this area must be 2A. So now we can talk about the ratio of OSV and QRUT. So the area OSV is the entire triangle area. It has the area 4 and 2, 6A, and QRUT is the shaded area. So the shaded area is A plus A, which is 2A. So their area ratio is 3. The answer is C. 32. OA and OD are perpendicular to each other, and this is alpha, that is also alpha. This one is 36. So the summation of all these three is 90. So from here we can find alpha as 90 minus 36 is 54, divided by 2 is 27. So the answer is B. 33. Point O is given in terms of p, and p is an integer. We're asked to find all the possible values of x. So p plus 4 is the x coordinate of O, p minus 6 is the y coordinate, and we know that since it is in the fourth quadrant, our x value is positive, which means p plus 4 is larger than 0, and p minus 6 is our y coordinate. Since it is in the fourth quadrant, we know that our y is negative, which means less than 0. So from the first expression, we have p greater than minus 4. From the second expression, we have p less than 6. So our p is bounded between minus 4 and 6. So to find out all the possible values of x, we can sum up all the possible values of p. So it starts from, since it is integer, it starts from minus 3, minus 2, it keeps going, and we have plus 4 up until 5. 6 is not included. So starting from minus 3, it's going to cancel out with the positive counterpart. So we're going to start the summation from 4. So we have these two numbers only. So 4 plus 5 is our sigma x, which is 9. So the answer is E. 4. The three bisectors are given. Alpha is asked. So let's see, this is x, that is also x, and this is y, and this one is also y. So from the triangle ABC, we know that the summation of the three interior angles make 180. Dividing both sides by 2, we have x plus y plus 33 is equal to 90. From here we have x plus y is equal to 57. And from this triangle, we know that the summation of the two interior angles is the same as the exterior angle, which is alpha. So x plus y is alpha. So our answer is C. These three lines are parallel. Given A plus B is that. Since these lines are parallel, we can make use of the similarity theorem. So 2 over 5 in this triangle is equal to A over 20. So 2 over 5 is A over 20. From here we have A is equal to 8. And in the same way, when we take a look at this triangle, we know that b over 15 is same as this ratio. So since this is 2 and 3, we can take the ratio as 2 and 3 over here too. So this over that. So 3 over 5 is equal to b over 15. So from here, we have b is equal to 9. So a plus b is equal to 17. The answer is C. 6. DC is parallel to AB. Okay, we're asked to find x. From these two triangles, we know that the ratio of this 3 and 5 is the same as side ratio 3 and 5 or 3 and 5. Okay, these are the ratios, so I'm not going to write 3k, etc., but you know that this is not 3 exactly, but the ratio is 3 over 5. Okay, so let's talk about x in these two triangles. So x over 4 is equal to 3 over 5. From here, we have x is equal to 12 over 5. So the answer is B. 7. A, B, C, D, E, F is a regular hexagon, and this is a square, and we're asked to find alpha. So we know that each angle of the hexagon is 120. So since this is a square, this one is 90, and this angle is 30, so that this one is 120. And this length and that length are the same, and this is also the side length of the hexagon, so we have an isosceles triangle over here. So since this angle is 30, this must be 75, and that is also 75, so that we have the summation of the interior angles as 180. So this is 90 since this is a square, so the summation of this and alpha must be 92. Since this is 75, alpha is 15. So the answer is A, 38. EC is 4 and AE is 16, and this one is 8 root 5, and this is a parallelogram. We're asked to find the area ABCD. So the area for parallelogram is base times height. So the height is known, part of the base is known. If we know DE, then we can find the area. So let's say this is x, then the area is x plus 4 times 16. Okay, since this is a root 5, we also know that this side is also a root 5. And 16 is 8 times 2. Since we have 8 over here and 8 over there, DE must be 8 times something. So we can find that something by using Pythagoras theorem. So DE square is root 5 square minus 2 square. Okay, this is 5 minus 4, which is 1. The square root of 1 is 1, so we have 8 times 1, which is 8. So we found DE. So let's substitute 8 over here. We have 12 times 16, so our area is 192. The answer is B. 9. CM is 5 and MD is 19, and ABCD is a tangential quadrilateral, and AD is a diagonal. And we know that KM is a diameter and this is perpendicular, so AC must be the same as KM. It's also a diameter and this is a radius, so AL and LC must be the same since point C is the external tangential point. So if this is 5, that is also 5, because they are both tangents. And if this is 5, that is also 5. They are both radius. So now we can make use of the Pythagoras theorem. This is 10 and this is 24. 10 is the same as 2 times 5 and 24 is the same as 2 times 12. So since it is the twice of something, so the hypotenuse is also twice of something. That something is 5, 12, so we have 13 over here. So the answer is 26E. 40. CD is equal to 2. And O, B, and C are, these 3 points are the centers of the 3 semicircles given here. We're asked to find the shaded region. So since this is radius, that is also radius, it must be 2. And from center O, this one is radius, so this one is also another radius. They have the same length, 4. And to find the shaded region, we need to subtract this region from the semicircle with diameter AD. So let's find the whole semicircle with diameter AD. So it is pi radius square over 2 minus, we need to subtract this region. This region is pi radius is 2 r squared divided by 2, since this is also a semicircle. So let's factor out pi over 2. We have 16 minus 4, which is 12. So we have 6 pi as the result. So the answer is E. This is the end of the math part of the video. I hope you get something out of it. See you in the next one.